Hello everyone and welcome to my YouTube channel. Today I'm going to do a question on analysis of bill using moment distribution method. Uh, uh, I'll start with this question. Analyze the bill shown by moment distribution method and plot the bending moment diagram. Plot the bending moment diagram. Question carries 20 marks. So this question, the beam is supported at A, B, C, and D. It is simply supported at A, B, C, and D. Span AB is 12 meters, span B, C, 5 meters, and has a point load of 25 kilonewton. Span CD has a point load of 10 kilonewton, which is at the mid-span. So the first step is to calculate the fixed end moment. The sign convention that I've adopted is clockwise moment. Clockwise moments are positive, and clockwise moments are negative. So these are the formulas for calculating the fixed end moment based on different configurations, beam configuration. For instance, for span AB, we have a point load, we have a UDL of 12 kilonewton per meter. So the formula we'll use this formula. So let's try it right away. So for the fixed end moment, M AB, we use, since I'm assuming fixed end moment is in that direction, anti-clockwise, it will be negative W L squared all over 12, which is the UDL. So if you work out that, you'll get negative 12 times 4 squared divided by 12. You'll get this is negative 10 kilonewton meter. So for fixed end moment, BA, it will just be positive 10 kilonewton meter, right? Now for span BC, it has a point load, which is not in the middle. So we are going to use this formula right here. So you'll have BC, fixed end moment, BC will be negative, equal to negative W A B squared all over L squared. So if you look at this diagram, this will be our A and this will be our B, right? So if you work out that one, you'll get negative 25. Our point load is 25 kilonewton here. It will be negative 25 multiplied by 2 multiplied by 3 squared divided by our length is 5, so it will be 5 squared. So if you work out this, you'll get negative 18 kilonewton meter, right? So now to work out M C B, again, you use the same formula, but now it will be A squared multiplied by B divided by L squared, which will give you positive. Now this is positive column, positive 25 multiplied by 2 cube multiplied by 3 divided by 5 squared. If you work out this, you'll get 22 kilonewton meter. Now we come to span CD. So MCD, you will use this formula right here. First one, WL all over 8. This point load is at the middle that makes conductor using this formula. So this will be positive. Sorry, the sign convention that I'm using is anti-clockwise moment, negative, so it will be negative like that. So this one is turning anti-clockwise like this. So if you work at them, you'll get negative 2 times 10 divided by 8. If you work at this, you'll get negative 6 kilonewton meter. All right. So to get M D C to be now positive 6 kilonewton meter. So now you are done with the first step. You are done with the first step. Remember, the first step is to calculate the fixed moment. So you must be very careful and get the fixed moment correctly. If you don't get it right here, the rest of the working will be wrong. Now let's proceed down to the next step. The next step is to calculate the distribution factor. So step number 2 is calculation of distribution factor. Step number 2. Step 2 is to calculate the distribution factor. Now I have prepared a table here. We only have 2 joints, that is joint B and joint C. So you prepare such a table. And remember, if the far end of the, if you are at a joint and the far end is pinned, the relative stiffness factor is this one, 3EI over L. If it is fixed, it is 4EI over L. So our joint, if you are standing here and the far end BA, it is pinned, so we are going to use 3EI over L. Again, if you are standing at joint B, you are at C. This is an intermediate support. For intermediate support, we treat it as a fixed support. So this is also for intermediate support. Also treated as a fixed support. So we are going to have 4EI over L. Again, if you are at C, CD will be 4EI over L and CD will be 3EI over L. Let me go straight to the working. So here we have said it is 3EI over L. So, and since our EI is constant, so the relative stiffness factor will be 3 over 4 over 4. And for span BC, 4EI over L, which will be 4 over 5. So the summation of this will give you 31 all over 20. So 3 over 4 divided by that 1 over 20, you will get 15 all over 31. And here you'll get 15 all over 31. Remember, these two should add up to 1 always. So distribution factor at a joint will add up to 1. Again, if you are at C, joint CB, since it's at intermediate support, it will be 4 over 5. That will be the same as this one. Then the other one will be 3EI over L. Our length is 3 meters. It will be basically 3 all over 3. Right? If you add up this one, they'll give you 9 all over 5. Now, 4 over 5 divided by 9 over 5, this will again will give you 4 over 9. And this one will give you 5 all over 9. Again, these two should add up to 1. Now let's proceed to step number 3. Step number 3, we are going to carry out now the distribution factors. Remember at joint A, we have said the end is pinned. With the joint is pinned here, the distribution factor here will be 0. Joint BA, this is BA. Please remember BA. You already calculated the distribution factor here. For BA is 15 over 31. So this will be 15 all over 31, and this will be 2 all over 31. Let me do this properly. This will be 2 all over 31. Again, this will be 4 all over 9, and this one is 5 all over 9. This is a member CC, CB, CCD, yes, and this will be 0. Remember, we have already calculated those distribution factors, right? CB, CB, B, and BC. Okay, so the fixed moments we had already calculated, so we just feed them directly in this table. This will be negative 10, this will be positive 10, right? It will be negative 18, will be positive 4, it will be negative 6, and this will be positive 6. All right. So before you start distributing, and A, this one is pinned, this one is pinned, pinned, and this also pin support. So we are not going to do any distribution here, so we need to release both joint A and B. So release A and B. How do you do that? So we add an equal and positive equal moment here, and half of that is transferred to joint B. So we add plus 8 here. We do the same here. We add minus 6. And we add here minus 3. And we close there. So this is now, we'll have a new moment. This one will be basically 0. It will be plus 24. This will remain 18, negative 18. Also will remain positive 12. It will be negative 9. And this will be 0. So we are not going to do any distribution here. Okay. Thank you. Here. Normal distribution. Okay. Take note of that. Now we start now the actual distribution. So we do our first distribution here. Remember when you're distributing, we look at joint B. What is the out of balance moment? It is 24 minus 18. And that will be positive 6. So the balancing moment will be negative. So we distribute 6 according to the distribution factor. Yeah, so it will be 15 all over 31 multiplied. Remember, if the out of balance moment is positive, the distributing moment or the balancing moment will be negative, multiplied by negative. That is for BA, the BA. If you work out that, you will get negative 2.903. So you do the same for BC to be in all over 31 divided by negative 6, and you get negative 3.098 kilometers per meter. So you will just come and feed this value here. This will be negative 2.903. This one will be negative 3.098. So you do the same here. If you work out the out of balance moment here is positive 3. So if you work out here, you'll get 1.3, and here you'll get 1.667. So the next thing you do is to do the carryover. Remember, for the pin joint, you don't do any carryover. So the carryover will be on this side. Half of that goes in that direction. Okay. And sorry, the balance moment here will be negative here and also negative here, because the out of balance moment is positive. It will be negative 1.3 and negative 1.67. So this is 3. So and half of this comes on this side. All right. So this will be, if you do that, this will be negative 0.67, right? And this one will be negative 1.54. Again, now you distribute this moment. Remember, it is negative, so the balancing moment will be positive. So if you do that, you will get negative. So this is the carryover. So we distribute again, distribute. So this will be negative. So the out of balance here is negative. So the balancing moment will be positive. will be positive. Yeah, this one. Sorry. So, so the balancing moment here, remember the whole of this is zero. So it will be positive 0.32, 0.32, right? Let me write down a bit lower. So it will be plus 0.32, and on this side it will be positive 0.34, 0.34, and again on this side, you distribute this 1.54, it will be positive uh, positive 0.17, 0.17, and on this side, sorry, I made a mistake there. So it will be positive 0.68, 0.68, and here it will be 0.86, 0.86. Again, the next thing you do you carry over. So if you do the carry over, um, so half of this, half of this goes to this side, and half to this side. So we'll get 0.34, yeah, right? And on this side, we get 0.1 together. We are going to distribute this. So remember, the balancing moment will be now negative. We are going to distribute again there according to the distribution factor. So if we do that, we'll get negative 0.17 on that side, and here approximately 0.17 to decimal place. And if you distribute on this side, you'll get 0.07, and here you'll get this is a negative, remember, negative, and this one will be negative 0.09, something like that. So if you start getting that now, we can now do the final moment here. Final moment. I've done it to two decimal places, but you can if you want to get more accurate answers, you can do it to four decimal place. This basically will be 0. So if you start adding from here, from 24, 24 all the way down here, you'll get something like 21.25, right? That is negative, not positive, and this one will get 21.25. 9.25, then you'll get 9.9, 9.9, and this one will get negative 9.9. Okay, and this one will be basically 0, 0 there. All right, so that's how you do the moment distribution. It's usually the last step. So now let's now come and plot the bending moment diagram here. First of all, you need to calculate the sagging moment between span AB. So the sagging moment is basically uh, sagging for span AB, so WL squared all over 8, which is 12 times 4 squared divided by 8. This will get 24. Right, so if we have to draw a straight line here, uh, so the sagging moment here, uh, yeah, so this will be positive 24. So the sagging moment between span AB will be, between this thing, it will be WAB all over L, which is 25 times 2 times, the distance here is 3 divided by 5. So that if you work out that, it will be 5 times 6, that will be shorter. So this will be slightly bigger, 30. No. At the moment, it will look like that will be a triangular, be a triangle, the maximum, yeah, it will be 30, 30, this will be 24. And finally, sagging moment between span CD will be WL all over 4, which is school times 3 divided by 4 will give you 12. Right, so 1 by 4, so that's 12. So it's going to just be a small value of what here. Okay. So remember, all these are positive. These are the sagging moments. Now, when it comes to plotting the hogging moment, we already equated here. For span, this is negative 21.25 with some here. Negative 21.25, and this one is 9.9 there. So, and of course, the edge is 0. It will be something like that. So this one is negative. So this is 21.25, and this is 9.9. So basically, that's how you do that question. So remember to subscribe and share this video and give it a thumbs up. Thank you.